Okay, in this video, we're going to look again at chapter 12.5. And we're going to look at problem 1286. By the way, I haven't been telling you, but these are all 13th edition. I just realized I haven't been saying that it's the 13th edition of the Hibbler Dynamics textbook. Okay, so my apologies, but I'm sure you'll figure that one out. Okay, so I want to do this one, 1286. Okay, that's what the motion looks like. It says when a rocket reaches an altitude of 40 meters, it begins to travel along a parabolic path given by this equation, this function, y is a function of x, where the coordinates are measured in meters. If the component of the velocity in the vertical direction is constant, Vy is 180 meters per second, determine the magnitudes of the rocket's velocity and acceleration when it reaches an altitude of 80 meters. Okay, so it's curvilinear motion. There's a lot of information. Where do I start? Where do I even start? Well, so the curve looks something like this, and it goes like that. And this is given by y minus 40 squared equals 160x. It's x and that's y. Okay, so this problem, if you go back to example 1210, example 1210, if you can do example 1210, this is exactly the same. Okay, this is exactly the same. So what do we notice here? We've got y basically as a function of x. We've got no x as a function of time data, no information. So what do I always advise you to do? You can use your own technique, but I'm the teacher and I'm advising you. What do? We start off with our position vector. We just, what is the question? I'm sorry. The question is, determine the velocity and the acceleration, the magnitudes. Okay, that's the question. Determine the velocity, the magnitudes of the velocity and the acceleration at y equals 80 meters. And altitude, guys, I hope you know what that means. Altitude means basically your height. So at an altitude of 80 meters, what is the magnitude of the velocity and acceleration? So if I want velocity, where do I start? I start with my position vector so that I can get my velocity vector. Okay? So what does this look like? We start there, then we increase the information. Xi, what is y? Y is given by this function. Okay? But let's rewrite it so that it's in a better form. Let's solve it explicitly. So y minus 40 squared is equal to 160x. If I rewrite this, I'm not going to go and solve this whole thing. But if I rewrite it, I'm going to get, I'm not going to do it step by step for you. Okay? Go and rewrite this, you're going to get this. And I just want you to take note. So this is what I'm going to get, plus 40. 12.5x to the power of a half, which is essentially the square root of x, plus 40 meters. Okay? I'm going to say this again and again as I go through this problem. I've rounded off here. Okay? I think it was something like 12, I forget now exactly what it was. 649. Okay. I made a mistake with, for some reason it's 12,649 and I wrote down 12.5. Okay? So I just want you to take note that I made a mistake here, but I don't have time now to go and recalculate this and redo the whole problem. So please take note that on my calculator, I got 12.649, but then I wrote down 12.5 and I did the whole problem using 12.5. Okay, so my apologies for that, but just, you know what I'm saying? Just get the idea of how to solve this problem and note that I've made a mistake there. And everything I do that follows is using this value, not 12.649. Okay? So anyways, So this is my y value, 12.5. Remember, that's a mistake, but I'm using that value for the rest of the problem. 12.5 x to the half plus 40. That is my my y position, right? Meters. So now if we want velocity, we know that velocity is dr dt, okay? But because we do not have x as a function of time explicitly, we are going to have to use the chain rule, okay? So v is equal to, what's that? X is just vx, I don't know why this is not focusing. There we go. Isn't it just terrible when things are not in focus? Yep, it is. Okay, so now we need to use the chain rule for this. Why do we need to use the chain rule? Because we have some kind of power, okay? Go back and revisit the chain rule, revisit your calculus. So what would be the chain rule for this thing? Remember, the chain rule is given by dy dt is dy dx dx dt. Okay, so it's these two terms. So what is dy dx of this? Dy dx of that is going to be 6.25 x to the minus a half. That's dy dx. That's dy dx. But then we still need dx dt, which is just vx. Again, note 12.5 is incorrect. It should be 12.649, but I wrote it down incorrectly and I solved the whole problem like that. Okay, and you'll see I got quite a large error at the end. Okay, so this is just the chain rule. And then the derivative of 40 with respect to time is 0, okay? So this whole thing is then our y component. That's our y component, meters per second. Vxi plus 6.25x to the minus a half Vx. Chain rule. Chain rule, my friends. Chain rule. So what is the magnitude of my velocity? That's what we're after. That's the question. What is the magnitude of velocity? Well, Vx squared plus this whole thing is Vy. This whole thing in front of the J is Vy. So Vx squared plus Vy squared square root. That's the magnitude. Okay? But we don't have Vx. And I don't have Yx. So what must I do? Let's try and solve the terms in here. What is x? How do I solve for x? Well, I can use this function here. I can use that function there. Again, that's incorrect at 12.5, but I'm using it. It should be 12.649. So I can use this. I know we're looking for x at y equals 80. So y equals 12.5 x to the half plus 40. I make that equal to 80, and then I solve and I get x is equal to 10.24 meters. Okay, again, you're going to get a different value because you're going to use 12.649. Okay, so now I've got x. Now what is Vx? How would I calculate Vx? Well, I know again that Vy, this whole thing is Vy, and Vy is equal to a constant 180 meters per second. I'm not sure if I mentioned that in the beginning, but if you look in the problem, it says Vy, there's a constant vertical velocity of 180 meters per second. So I know Vy is 180, and I know that this whole thing there is Vy, which is 6.25 x to the minus a half Vx. Okay? And I know x is 10.24, so x to the minus 10.24 to the minus a half will go, well, that's what that will be. And if I solve this, I know what x is. X is there. If I solve this, I get Vx equal to 93.3 meters per second. Okay, again, you need to calculate the correct one. I'm just showing you the procedure. I made a mistake here, but it's not that far off. But you know, not that far off is actually, it's still wrong. Okay, so what is our velocity? The magnitude of our velocity, Vx squared plus Vy squared, square root of that. So it's 93.3 squared. And what is Vy? That is given as 180 squared. And if we get the answer, I calculate 202.7 meters per second. So that's the speed. I think the answer in the back of the book was 201. So I'm not that far out. But guys, please just take a look at the methodology. Okay. Okay, so then the next thing that we want to do is we want to calculate the magnitude of the acceleration. Magnitude of acceleration. Acceleration is AXI, acceleration vector, plus AYJ, meters per second. And we know A is dV dt. What is V? V is given by this. It's given by this. All right. Remember, that's a minus a half. Okay. So let's rewrite that. So A is d dt of V, which is Vxi plus 6.25. Again, that's wrong. Okay. X to the minus a half Vx. That whole thing, this whole thing here is Vy. All right. So now, recall in class, I hope you were there, in not only in body, but also in mind. This whole thing is Vy, right? Well, actually, that's not what I was trying to say. Got sidetracked there. We've got two terms here. So when we take the derivative, ddt of this, we've got two terms. So we need to use the product rule. The product rule and the chain rule. We need both. Okay. So let's just first take care of this. Let's just first take care of this term. Do you see why I like to write it out like this? It gives me the big picture, and then I can extract one of those components, deal with it, and then put it back into the big picture. Okay, so let's do ddt of 6.25 x to the minus a half Vx. We need both the product rule and the chain rule. What is the product rule? The derivative of the first times the second, plus the first times the derivative of the second. But this one, you need to use the chain rule for the first one. So, remember, so d of uv is du times v plus u times dv. Derivative of the first times the second plus the first times the derivative of the second. Very good. Okay, but the first, the derivative of the first, we need to make use of the chain rule. So what is that going to be? So remember, that's dy dt is dy dx dx dt. So let us look at this. This is going to be, if I can just find my notes, that is, the derivative of that is going to be minus 3.125 x to the minus 3 over 2, right? That's just that first term, dy dx. Then I need to put that in as well, dx dt, which is Vx. Okay? Now that is just the first term. That's just the first term. Then I need to put in the second term as well. Okay, so what is dy dt of that first term? I need to use the chain rule. Dy dx of that first term goes there, and then dx dt of that first term goes there. Then I still need to multiply by the second one using the product rule. Okay, then that's the first term. Then the second term is going to be 6.25x to the minus a half times the derivative of the second one, which is vx dot. All right, so if I rewrite this, so now I can put it back in here. Acceleration ddt, what is the ddt of this? It's ax times I, plus, now I can put that whole thing back into the acceleration vector. Minus 3.125 x to the minus 3 over 2 vx squared plus 6.25 x to the minus a half ax. And this, I'm going to put a plus there, and I'm going to put the brackets like that. J meters per second squared. So there's my ax, and remember this whole thing here is my ay. This whole thing in front of the j is my ay. So now a, the magnitude, again is ax squared plus ay squared square root. Okay, again, how are we going to solve this? We want to find the magnitude of acceleration. We don't know what is ax. What's ay? We know ay should be 0 because vy was 180 meters per second. It's a constant. So this whole thing, as I just mentioned, is ay, and it equals 0. So ay equals 0 equals minus 3.125 x to the minus 3 over 2 vx squared plus 6.25 x to the minus a half ax. Okay, I hope you guys are still with me. Recall, I'm just going to repeat again that these numbers are probably wrong because I made a mistake in the beginning, but hope you're getting the idea. So what is Vx? Vx was, we calculated that to be what? I calculated to be 93,3. And x was 10.24. And so and there's another x, 10.24. Remember, this is to the minus 3 over 2, and that's to the minus a half. So if I calculate ax here, I get 425 meters per second. Okay. Again, you'll probably see that is quite off from the answer in the back of the textbook. But please forgive me my initial mistake. Hopefully you're getting the big picture. And we know that ay is 0, so that is our magnitude. The magnitude is 425 squared plus 0 squared square root, which is just 425. Okay, hope that helps. Hope you have a good weekend. Hope you study hard. Good luck. See you next week. Cheers.